Welcome to the channel. So here we discuss about pharmacognosy, phytochemistry too, in that various extraction method. So supercritical fluid extraction, this is the modern method of extraction. So why this extraction method generally investigated? Because extraction and isolation of natural product from various sources, it generates large amount of waste organic solvent. The industrial waste are really hazardous to the human health, and there is that's why there is a continuous regulation in the use of industrial solvent has been increased. So here that's why most of the industry use the supercritical fluid as a solvent for the extraction because it is clean, safe, inexpensive, non-inflammable, non-toxic, and environment friendly. So this process of separating one components from the another components using supercritical fluid as the extracting solvent. So supercritical fluid means what? It is any substance at temperature and pressure above the critical point where its distinct liquid and gas phases do not exist. Above the triple point, that is the critical phase when we increase the temperature and pressure, then it behaves like a fluid is known as a supercritical fluid. And this supercritical fluid generally used for the isolation purpose. So here is the phase diagram. Here is the temperature on x-axis, pressure on the y-axis. So here is the solid phase, vapor phase, and liquid phase. So these are the exist if the temperature and pressure is in under control. At the triple point, this is the critical point. So above the critical point, there is the supercritical region. So if we increase the temperature as well as the pressure, then it behaves like a supercritical. So critical condition means what? At a certain temperature and pressure condition, liquid and vapor phase of the substance become indistinguishable, known as a critical point. And substance above the critical point is known as a supercritical fluid. Then what are the properties of this supercritical fluid? Physical and thermal properties of SCF in between the pure liquid gas, hence it is known as a compressible liquid or the dense gases. If changes in the property of SPF as follows, like liquid like density like 100 to 1000 times greater than gases, diffusivity higher than liquid, that is 10 raised to minus 3, 10 raised to minus 4, then it has a good solvating power, reduction in surface tension, low viscosity, gas-like compressibility properties. Therefore, they possess high penetrating power. Then what are the historical background? So this method is investigated in the year of 1879 by Haney and Hauger. They measure the solubility of inorganic salt in supercritical ethanol. So since 1980 to 1990, SCF has been used in several industrial processes. So here is some substance. They behaves like a supercritical fluid. If so, here is the temperature condition, pressure condition, uh, atmospheric, and the uh, pressure square inch. So carbon dioxide, if temperature is 13.1 and pressure 70.4, then it behaves like a supercritical fluid. Then what are the difference between the conventional method and supercritical fluid? So if we use the solvent, it passes through the solid, dissolved solute, extract out, and those are the solid dissolved into the solute. It get distilled or refined in the form of solid. So in supercritical fluid, same principle, but instead of the solvent here, we use the supercritical fluid. Then what are the principle if we use the carbon dioxide as a supercritical fluid? So these supercritical fluid are known to provide good reaction media due to their capacity to homogenize reaction mixture and due to their high diffusivity and controlled phase separation and distribution. It is mostly used for the herbal extract or for the making of the herbal extract. So next is the instrumentation. So here is the assembly. So this is the cylinder. This here is the pump. Here is the extracting cell, and here is the uh, recycling phase. That is here we collect the supercritical fluid by trapping method, and here is the recycling pump. So due to this, it is again compressed and it is again converted into the gaseous state. Then what are the steps for this? Feed the material into the extracting assembly, pass the CO2 at pressure 100 to 350 bar, and extraction material is dissolved into it. And from the extractor, along with the extraction fighter, it is sent to the separator via pressure reduction valve.